Hello and welcome back to another episode of Math with Sound. Today we're going to be doing a torque problem where we have to do a few different things. So the first thing is just define torque of a couple. Okay? So torque is equal to the product of one of the forces, perpendicular forces, times the distance away between the pivot point. So I'm going to write down the product of one of the forces and distance between the forces and the perpendicular distance. Force perpendicular times the distance from pivot. Okay. The actual definition, according to the ACE, is torque is the product of one of the forces and the distances between forces, the perpendicular distance between the forces. So there's two different things. Perpendicular gets you 1 point, and then the product of one of the forces and the distance between the forces. I would say the distance between the pivot points, so that was what got me a little confused there. So here we have a uniform rod, length 1.5 and a weight of 2.4 as shown in figure 2.1. The rod is supported on a pin that passes through it, so it's going to be able to pivot and rotate around this or not rotate depending on the circumstance. It wants to calculate the torque on the rod produced by ropes A and B. Both A and B have a 8 Newton force, and they are both perpendicular to it, so we don't have to worry about sine of the angle. And they are both 0.75 away when you take that 1.5 and divide it in half. Okay? So the sum of all torque in this situation is going to be 0.75 times 8, and that is going clockwise, so I would say that would be a negative 0.75 times 8, and then this is also going clockwise, so that would be another negative 0.75 times 8. So both A and B are considered clockwise. That's why I put them both as negative. And when you do the math for this, you end up with a torque of 12 newtons per meter. I would claim that it is negative 12 newtons per meter, and it's kind of odd that they don't have a magnitude here. So we're just going to write negative 12 newtons per meter, because clockwise convention is considered negative. Counterclockwise is considered positive. Discuss briefly whether the rod is in equilibrium. The answer to that is heck no. It is rotating clockwise. And if it is in rotation, then it is not in equilibrium. In order for it to be in equilibrium, the sum of all torque has to equal 0, and the sum of all forces has to equal 0 if it is in equilibrium. And that is not the case here, therefore it is not in equilibrium. Okay? The next part of this question is asking us, so we have here, we remove the pin. And when we remove the pin, we now have rope A and rope B that are holding this up in equilibrium. And the task is to find the tension in rope A and to find the tension in rope B. So that's our goal here. I'm going to do it down here where I have more room. So rope A is 0.45 meters away from the rotational middle. And I'm going to claim that this is the rotation spot still. Okay, you can claim the rotation is at any spot mathematically. I'm just choosing to make it the middle. Rope B is still 0.75 meters away from the middle. Okay, so now because it's in rotational equilibrium and translational equilibrium, that means that 2.4 is going to equal the force of A and the force of B, or the tension in A and the tension in B, which is not going to enable us to solve what the tension of A or the tension of B is. But we could also recognize that the sum of all torque has to equal 0, and B is going counterclockwise, and A is going clockwise. Okay, so there's two ways to do that. That means that you could say the torque due to A is equal to the torque due to B, or the torque of A minus the torque of B is equal to 0. This is the one that typical people would prefer, torque A minus torque B equals to 0, but I prefer torque A equal to torque B. It depends on which way you're dealing with it. So I'm going to do torque A equal to torque B because those have got to be in equilibrium because it's not going to rotate. All right. So that means that this is going to be 0.45 times the force due to A, or the tension in A, must equal 0.75 times the force due to B, or the tension in B. Now, I am going to solve for one of these. And I'm going to choose to solve for I'm going to choose to solve for B. 2.4 minus A would equal B. This I can substitute in for B. So this would be 0.45A would equal 0.75 times 2.4 minus A. And then we just solve. All right. So we got to distribute the 0.75. 0.75 times 2.4 is 1.8 minus 0.75 of A is equal to 0.45A. And then we just add that 0.75 over. 0.45 plus 0.75 ends up equaling 1.2. Tension in A is equal to 1.8. All right, so we divide 1.8 by 1.2, and we get A is equal to 1.5 newtons. Well, A is equal to 1.5 newtons, which means that B, because 2.4 is equal to the tension of A, which is 1.5 newtons, plus B, then we just subtract 2.4 minus 1.5, and we get B is equal to 0.9 newtons. So the trick here is the recognizing that both of these have to hold the pole up, and the sum of all torques also have to equal 0. So you can create a system of equation with that. That is going to do it for this one. Until next time, I will see y'all later. Bye.